Yeah, good morning, students. Today too we are continuing our lectures, our tutorial on calculus. This is calculus 4. If I say calculus 4, what do I mean? Calculus 4. I'm naming it calculus 4 because we are treating calculus in series. So today we are moving to calculus 4. We are moving up to, I think, the calculus up to the 6th one. And let me tell you once again that you have to subscribe to Calendarman TV, okay? When you subscribe to Calendarman TV, make sure that you press the notification bell so that any notification that you have, any video that we post, you will get it. Otherwise, if you just subscribe, you will not get it. And you know how to subscribe. I think it's very straightforward. You just see that red, just type Calendarman TV on YouTube, and you type, and then you go there. So today we're going to talk about the first order and the second order differential equations. Okay, first and second order differential equations. You know, when we talk of first order differential equation, for example, if I have, let's say, dy dx plus, let's say, 3y is equal to, let's say, 4. This is first order. But if I say, let's say, the squared y over the x squared plus, let's say, 8y is equal to, let's say, 14. This is a second order differential equation. Why? Because of the square here. You understand? So that is what we have. So if it moves to the third side, then we have the third order differential equation. Okay. So without wasting much time, I think we have to look at, as I've already told you, you'll be limiting projections. If I say we'll be limiting projections, we will try as much as possible to actually avoid projecting too much, but we rather write the question on the board. So that when you see me looking onto the paper, I'm just trying to write the question as it is, then we pick it from there. So under this first order differential equations, that means still we are under differentiation. You can just imagine. You want to talk about what you call the general equation. And under the general equations, we shall need what we call the we call something a particular integral, and then you have what we call the complementary function, and then particular integral, okay? Yes, particular integral. So what is going to happen is that our general equation, that is our y general equation, is going to be y complementary plus y particular. It looks a little bit interesting, but when we start, I hope you're going to get it. So the question is, they say we have to write down the what? The general equation. Write or find what? The general equation for, let me see it, for example, dy dx minus y is equal to x. Interestingly, I try as much as possible to avoid a lot of mathematical theories. So in doing that, what we normally do is that we say that our y, which is the our complementary function, is given by mx. Okay, now just follow me. Emx. This thing that I'm doing, we are going to substitute it into something, and you get it. So in this case, this y is what? It's given by emx, and you know this natural logarithm and this this base. So what is dy dx? So dy dx, we learned that here you have to define this with respect to x. So I'm going to have what? E mx. I guess I've done this with you already. So look at these two numbers. Just remember this one and remember how we differentiated this one. So over here, we are just going to put, so if this is equation 1, we are going to put this into what? Into equation 1. Okay? We are going to, I'm repeating, we have been asked to find the general, or write the general equation. And to find the general equation, this is the equation they have given to you. So just try and remember, there's no need in memorizing this one. Here, y is equal to what? E, that's the base E, mx. And we learned that if you want to differentiate this, we differentiate this one, and we get what? E, mx. Okay? Now let's look at the next step to go. Okay? So over here, we are putting it inside. What is dy dx? Dy dx is what? Is E mx, okay? Dy dx minus our y, which is what? E mx, okay? But in this case, you
action.
Yes, so in solving this, what we are saying is that I'm going back to my step. In solving this, we let this whole thing be equal to 0. So if this is equal to, we let the y dx plus minus y is equal to 0. So it means that this is equal to what? 0. And therefore we assume x here, we assume x to be what? To be 0. Now look, watch here. If you want to factorize, you are going to have e, okay, mx into bracket what? M minus 1 is equal to 0. But over here, in fact, e mx is not equal to 0. So if e mx is not equal to 0, then we are going to have m minus 1 is equal to 0 because this is not equal to 0. So m is equal to what? M is equal to 1. Okay? Now after getting our m is equal to 1, then we come back to this complementary function, that is, we said that y is equal to what? E mx, and m is equal to 1. So y is equal to, now what happens is that in a complementary function, you assume here to be a, so a, e, instead of writing y here, so it becomes what? A, e, x. Exactly. This is what? A, e, x. So you have to note it down. This is a complementary function. Then, after getting that, then you come to the second phase, which is the particular what? Integral. Particular what? Integral. Okay? Particular integral. Right? So under the particular integral, here once again we have a very interesting, I'm going to say that y p is equal to ax plus b. Here once again we want to substitute, so y is equal to ax plus b. So, and this is the yp or y particular integral. So dy dx. If you differentiate this, you are going to get what? If you differentiate, you are going to get what? A. Okay. So once again, we are going to put this thing that we have into the original equation again. So over here, I can now clean it and then put it there. It will be recalled that we have, what is the original equation? You know, where is the original equation? The original equation is dy dx minus y is equal to x. This is the original equation. In this case, here now you maintain the x. Here, this time the x comes. What is our dy dx in this regard? Our dy dx is a minus y. What is our y? Our y is ax plus b, okay, is equal to x. Okay, ax plus b is equal to x. So if I open the bracket, it's going to be what? A minus ax minus b is equal to x. So let's look at it carefully. So here it's going to be what? Minus ax plus a, is that correct? Yes, plus a minus b is equal to x. Now, I want to compare the coefficients. So comparing the x coefficient, you say that, watch here. In fact, here is 1x. So if I compare coefficients that are bearing x, here becomes negative a is equal to what? 1. So a is equal to what? Negative 1. Exactly. A is equal to negative 1. Please, I hope you've copied this side. A is equal to what? Negative 1. Then how do you find the b? Look here. Here, this one, those that are not bearing x, we say that a minus b is equal to 0 because a minus b is not having any. It is only x that is having coefficient. So a is equal to what? B. So if a is equal to b, then b is also equal to what? Negative 1 because a is equal to negative 1. So they are the same. Now, after getting this, then we are going to write our general what? Equation. Okay? And the general equation is going to be our what do you call? We're going to have the general equation in two forms. That is, over here. Let me say something here. Right now, after getting your A, so now we have had our A, and we have had our what? Our B. So what is it? So our y particular integral, we have what? Ax plus b. So what is our A? Our A is what? Negative 1. So negative 1 is the same as negative x. Negative 1 minus b. B is also what? Minus 1. I'm repeating. Ax plus b. So here is what? Negative x, negative this. Because we have put these values. A is called negative 1, b is called negative. I'll put it inside. Therefore, we say that general equation, that is y general or general equation, is going to be complementary function, which is what? Ex minus x minus 1. This is the general equation that we want. This is the general equation that we want, where a is constant. Exactly. I think you have to look at another example if you are okay. How did you do it? First, we have cleaned the first part, but just follow the steps and you'll be able to understand. So this is the general equation. We are moving a little bit deeper, okay? We are moving a bit deeper and deeper because right now we started from the fundamental and now we are moving into the deep waters. So I believe that you have to follow us as such, okay? Let me see if I can get another example that we can work. Here, he said you should find the general equation for dy dx plus 3y is equal to 2x. So here, we say that for what? For complementary what? Function dy over dx plus 3y is equal to 0. Okay? And as we said initially, we know that it follows the same sequence that for complementary function, you say that y complementary is given by what? Is given by e mx. Is that okay? E mx as exponent mx. Okay, this is our y or y complementary. So dy dx is equal to what? It's equal to m e mx. Okay. Look at how we are doing it. You just remember this one and know how to differentiate this one. Then after doing that, then we are coming to put this information back into this original equation. So what are we going to have? We are going to have dy dx is what? M E mx. I think it's bold enough, right? It's better. Okay. Plus 3. What? Y is what? E mx. Okay. Is equal to 0. And since E mx is not equal to 0, okay, we can now let's factorize first. We have E mx into brackets m plus 3 is equal to 0. Okay, and we said since we have E mx is not equal to 0, it implies that m plus 3 is equal to 0. So m is equal to what? Negative what? 3. Exactly. We've got m to be what? Negative 3. After getting our m to be equal to negative, I'm repeating. They gave you this expression. First, you equate this whole thing to 0. After that, just remember this particular expression. E is equal to what? Y is equal to E mx. Then you differentiate it. After differentiating, come and put the y dx in place of this, and come and put this one here, and equate it to 0. Now, we have put it there, and we have factorized E mx out. And we say, since this is not equal to 0, this part is equal to, and so m is equal to what? Negative what? 3. Exactly. M is equal to what? Negative 3. So, if m is equal to negative 3, then of course, y complementary is equal to A, E, M, and M is what? M is equal to, what did we get for M? Let me check it from here. M is equal to negative, so in place of you put negative 3 here and then M. So this is your complementary function for that. This is your Y for the complementary. Now, so as I said, I'm repeating, I say M is equal to negative 3. So in place of we put negative 3 there, then the x is here. Now, we are coming to what we call, so this is our what? Our y particular. Then we come to the particular, the first one is complementary function, okay? So we are now coming to particular integral, exactly, particular integral. Now for particular integral, what did we say? I think we put some very nice information there by saying y is equal to ax plus b. So dy dx is equal to a. So once again, I'm going to put this information back into the original equation. This time, the 2x should be there. So in place of dy dx, I'm having what? A plus 3 what? Y. Where y is what? Ax, is that right? Ax, okay, plus b, okay, is equal to 2x. So I'm having a plus 3ax, okay, plus 3b is equal to 2x. If I want to rearrange, I'm going to have 3ax plus a plus 3b is equal to 2x, right? Now, let's equate the coefficient. Now, here I'm having what? 3a attached to the x, then 2 attached to the x. So if I compare the coefficient, I'm going to have 3a is equal to 2. That is x attached is this. So a is equal to what? 2 over 3. All right, let me cross check my value, making sure that it's correct. Yes, a is equal to 2 over 3, which is what? Correct. Okay, remember that we have already found the complementary function, so we now need a particular integral. Now, you want to compare the other ones which are not bearing x. And what are they? You know, we have a plus what? Plus 3b is equal to 0. Is that right? Yes. A plus 3b is equal to 0. They are not bearing any x. And we know a to be what? 2/3 plus 3b is equal to 0. So I can multiply through by what? By the SCM, which is 3. And here, times 3 times 3. So it becomes 2 plus 9b is equal to 0. So 9b is equal to negative 2. And b is equal to a negative 2/9. Okay? And b is equal to negative 2/9. Are you okay? I hope I can clean here. We are finding a general, what do you call, equation. Why general equation is what? Is complementary function plus the particular what? Complementary y plus particular y. So once again, so now what are we going to do? Now that we've gotten this, then we say that y general equation is going to be what? Because for now we know b and we know our a. Okay. Now, what is it? Over here, before we even move on, you know that y what? Y particular integral or y particular is going to be a. Where a is what? We have calculated a to what? 2/3, right? That is the a. A is, where did we get it from? This is our a. It is 2/3. Okay, remember that we picked the y from here. So 2/3x. Okay. Plus b. Where b is what? 2/9. 2/9. So this is y a particular integral, y particular. Therefore, y general or general y is going to be what? Or general equation is going to be our complementary function. Where is it? Which is a e negative 3x, okay, plus 2/3x minus 2/9. That's what I got. I calculated. And let me confirm from my paper. So that is what is actually transpiring here. Now, having gotten this, let me remind you, and I told you some time ago that there is a company called Forever Construction and Consultancies Limited that deals with land from Dodowa, Pienya, several places, Obudan, around between Nsawam and then Aburi. There's Obudan is there, okay, and then Awutu Breku and several places. Now you can call Forever Construction and Consultancies Limited for land that is litigation free, lands that are litigation free. Lands that are got demarcated roads with a lot of facilities that will definitely be helping you. With document, they will be assisting you in your documentation. Is that okay? So you can call 050 601 2820. Forever Construction 050 601 2820 or 0277 44 32 25. Okay. As we progress, I will mention Ashin Senior High School. You know that it's a senior high school that definitely helps you. As you are watching me, they have a very good teacher that will definitely be helping you to pass once and for all. Those of you in the SHS and other, doing other courses, they have very powerful teachers that will be helping you. Now, we have to move on. Now that we've gotten this one, all these we are talking about, we are on calculus, okay? Calculus 4. Calculus 5 what we are talking about. And we want to look at, before we started, I told you that we have the first order and then the second order differential. So I tried to, organize some of the second order. So we have to find the general equation for, says find out the general equation for d squared y over the x squared plus dy x minus 6y is equal to x plus 1. So, as usual, you have to remember, in solving it, what did we say? We said that y, for complementary function, say yc is equal to what? Y is equal to what? Emx. You remember, where mx is the exponent. So, dy dx. For this c is just for the complementary function. Dy dx will be what? Will be emx. And then, can I move down a little bit? Yes, I hope you are seeing it. Then we have the squared y over the s squared. I hope you remember. I taught you about the second order differential. So that's how we are differentiating it again. And that will be m squared e mx. Okay. So we are going to slot it into this one. But remember that for complementary function, you equate this to 0. So here we are having what? M squared e mx plus what is our dy dx? Our dx is what? E mx, exactly, minus 6. What is our y? Our y is what? Right now, no, here is m, sorry, there is m here. There is m here. And here is what? 6e. Let me write it clearer so that you see it in we are trying to substitute this information in this one. And that's what we are having. So we have what? I said we have what? The squared y is what? The squared y is what? M squared e mx. Okay. Plus dy dx is what? M e mx. Minus 6 e mx. All equal to 0. Please note this. So we have what? E mx, okay, e mx into bracket m squared plus m minus 6 is equal to 0. Now we are finding general equation. So first, what did we do? We first got this, and we have to get this one clear always, the complementary function. Then we differentiate this. But since it's the second one, then we have to re-differentiate. And after we re-differentiated, we got m squared e mx. I've taught you how to differentiate equations like this with e as base. Okay. So if e mx is not equal to 0, then m squared plus m minus 6 is equal to 0. And under the algebraic expressions, I taught you how to factorize. So over here, what do you do? In factorizing this one, you multiply this by that, and you get, so it becomes m squared, okay, plus what? 3m minus 2m. You can remember that because if then minus what? 6. Okay, it's equal to 0. Then we factorize m out. We got what? M plus 3. Then here is also what? M plus 3. Here is what? Negative 2. So we got m plus 3 into bracket m minus 2. If you want to get this basis, you can go to the algebraic expression that I taught you or explained. Is that okay? Go to algebraic expressions. Now we are talking about calculus 4. Calculus tutorial 1. 4. Now, in this case, we say that m is equal to what? Negative 3. And then m is equal to what? What? What is the m? M is equal to negative 3 and m is equal to what? Positive 2. So in this case, we've got to also, our y complementary function is going to be what? Here we are going to have A E M X plus B E mx. Now, so sometimes they use alpha here, beta here. Okay, so m1 possibly m2x. So it becomes A E. What is the first m? Negative 3 what x plus B E positive 2 what x. This is your complementary what function. Okay, this is your complementary function. Now, after that, then we are coming to the particular what integral. That is particular what integral. Okay, particular integral. So for particular integral in this case, since this one we have what y is equal to I just noted it down. Qx plus r is the same as ax plus b. It's here where these ones are all constant. Okay, q and r are constant. So over here, we say that dy dx is equal to what? Is equal to q. When you differentiate this one, you get q. Because this one, if respect to this one go up, this is constant. But the squared y over the r squared is going to be 0. It's going to be 0. When you differentiate this, you're going to get what? 0 for it. Exactly. You're going to get 0. Here, this will confuse you a little bit, but that is how it is. And what I'm interested in is the complementary function, which is this one. So we are now finding the particular integral. This is the second order. Okay? This is the second order of performing that calculation. So the reason why that place is 0 is like if you have, let's say, y is equal to, let's say, 3x plus 4. Let's take that. So dy dx would have been what? 3. So when you differentiate this 3, this one is like, the q here is a constant. So like if you differentiate 3, you get 0. That's what I want you to understand. So it's not a letter. Okay, we are talking about, we are treating calculus. And another calculus, we are on differential what? Equations. So we are now going to put this 3, 1, 2, 3, into the equation. What is the equation? What is the equation? You know, the original equation was what? The squared y over the x what? Squared. Plus dy dx minus 6y is equal to x plus 1. So now, let us plot these figures inside. What is the square one with the squared? 0. Plus, what about dy dx? Dy dx is what? Dy dx is supposed to be q. Minus 6y. And our y is what? Qx plus r. 6qx plus r in this case. Is equal to x plus 1. This is what you are having now. So if I open the bracket, I'm having q minus 6qx minus 6r is equal to x plus 1. So if I'm to rearrange, I'm having minus 6qx, okay, plus q minus 6r is equal to x plus 1. I'm trying to rearrange. First, I open this bracket. I'm now rearranging. Okay, this is 6r. Okay. Now I want to compare coefficients of those that are bearing x. So this is x. This is x here. So this is 1. So 1 here, and then the number attaching x here is 1. I'm having negative 6q is equal to 1. So q is equal to what? 1 over 6 negative. Negative 1 over 6. That is our q. Okay. Having gotten our q, we can now also find our the others. Now look here. We compare it. So the rest are what? We have q minus 6r is equal to 1. It is 1 which is left. Okay. So in this case, do you know q? Q is what? Negative 1 over 6. minus 6 r, okay, minus 6r is equal to 1. If I multiply through by even the 6, I'm going to get negative 1 minus 36r. I multiply through by the LCM. Is equal to what? Is equal to 6. I've multiplied through by 6. So here, negative 36r is equal to what? 6 plus 1. That will be what? 7. Therefore, r is equal to what? 7 over. Let me be very sure. I got 7 over 36. I is equal to 7 over 36, which is negative. Okay. We are moving deeper into the water, so but don't worry, that is how it is. Okay. We are finding general equation. Is that okay? So over here, this is our r. So now, how do you write our complementary function? Because we say that our particular integral, you know, we have yp is equal to qx. What is the q? Q is negative 1 over 6. Is that okay? X. Is that correct? Let me check and be very sure. Yes, X. That's our Q. Plus R. What is our R? R is minus 7 over 36. This is our particular integral. Therefore, if you are talking about the general equation, then we say that y general is going to be what? A E 3x, okay, plus B, yes, negative, B E 2x, I'm filling here, I hope you can follow. Then minus 1 over 6x minus 7 over 36. This is the general equation. This is the general equation for it. Is that okay? That's the general equation for it. Okay. So that is for you. So now, I think we have to continue with it. So at least you can be trying more examples under that. So I hope you have to move on. Now, I'm urging you to subscribe to Calendar Man TV because we'll be treating more. You know, after this calculus, you know, we have matrices there, we have a lot of topics there. Topics that people have started sending messages about the topics that they wanted to treat. We shall be treating all of them. But you see, the calculus was very urgent for certain specific reasons. The number of people who need the calculus, there are many. That's why we try to do that, and definitely we shall be doing that. So try and communicate to your children to do what? To do that. Now, because something the partial derivatives. I want you to know this. You know, we started talking about the second order differential. Okay, second order differential. Okay, so the everything has to go on silent. The phones. Okay. Now, partial derivative. Is that okay? So I want us to look at something in brief. If I have the square, this is what some students don't want to see, over the x squared. This is written as the x, okay? Then the z, the x. Note this, we are going to apply it for something. Then the square z over the y squared. This one will be the y. Interestingly. Then the z, the y. Is that okay? People don't want to hear the there. Then we have the square z over the x, the y. I want you to check something. Here becomes the x, then the z, the y. What is your observation? Look here. You could see that over here, I was able to pick one of the there out. Then I was left with this another z there. But here, it looks like the x squared. So this thing here and then another over there. Without wasting much time, I want us to look at a typical example so that's why I'm saying that mathematically sometimes we don't want to talk about too much theories. If I continue to mention this, the people will be getting confused about what we are talking about. So I don't want to go too much into that side. Let us see how best we can solve problem. So this is a real problem that's coming. He said find out the first and second order derivatives of z is equal to x cubed plus y cubed minus 3ay. Now look at this. You can see that it entails a lot. It's not differentiation whereby you just say differentiate dy dx. It entails x, it entails y, it entails a, it entails z. So how many letters are you seeing? You see z here, you see x, you see y, you see a. Are you following? And it is not difficult, please. Please subscribe to Calendar Man TV, okay? We shall be treating logarithms. Some people have started, they are bringing logarithms and other mensuration and other. We'll be treating all of them. So now, the first order derivatives. So let's start. I'm going to pick the one from after the other, okay? So which of them should we? So I'm having the z, okay? The x. That means I'm going to differentiate z with respect to what? To x. So that place, if there is no, oh sorry, I think there's x here. X before my y comes, okay? Over here, you are going to differentiate in such a way that you differentiate only at where we have x, okay? And you remember when we were treating, what do you call? There was implicit functions. We did something like that. Over here, there's x here. So here, if you differentiate this, it becomes what? It becomes what? 3x squared. Do you remember? Go back to it and check. Down here, if you differentiate this one, here is y, there's no x, so you don't go there. So here becomes what? Minus 3ay, because here is already to the power 1. So when you subtract, this one will vanish. Exactly. When you multiply this one here, this one is 1 minus 1, and it will be x raised to the power 0, so it vanishes. So this is the z, the x. Then I'm talking about the z, the y. In this case, we are talking about where we see y. There is y here. Okay, so I'm going to have what? 3y squared. Then once again, y will go minus 3ax. The y also vanishes. Now, so right now, we've differentiated the z, the x, and then the z, the y. Then they say, let me see. We have the square z over the x squared. Remember this one, I told you that this is the same as the x, okay? Then the z, the x here. So over here, it becomes the x. But we know we have already differentiated the z, the x. What's the z, the x? It is what? 3x squared minus 3ay. This is what you are having now. Exactly. Now, after getting this, but the same, you have to differentiate the x. That means you are differentiating at this x is telling you differentiate at where there is x. This one, look at this number, this letter. Because of this, if it is y, then you differentiate only y. So this is what you have to check. So here, if it is x, then we are going to have what? 6 what? X. Let me cross check, and it is correct over here. 6x, okay. Then we are talking about what? The square z over the y squared. This one is also equal to what? The y, the z, the y. So we have what? The y, okay. And we know the z, the y. What is it? The z, the y. We have calculated it already to be what? 3 y squared minus 3 ax. Is that okay? Now, don't get confused over here. Here, because of this y, look at where there's y. And it is what? It is 6y. That's all. Then you are done over there. Then after that, I don't know whether I can hit to this side of the board. I'm asking my producer about it. Okay, if I will hit this side and it will show, that's fine. Then we are talking about the square z over the x, the y. This will be what? The x, okay. Then the z, the y. So I can write the z, the y, which is what? So the x, okay. What is the z? The z, the y. I can get it from there. You what? 3 y squared minus 3ax. Okay. Now, because of this, it is telling you have to differentiate with respect to x and stop this one. So here it becomes what? It becomes, this one will go off, and it becomes what? Negative 3a. And that is it, exactly. So you have to take note as such, exactly. Now, there are many, but some of them I will give you it, you and go and then try your hands on and see if you'll be able to get it. In order to save time, we have a lot that we have to deal with. Exactly. So I've worked something, but I'm giving you this so that you try your hands. So I'm just giving you the answers to it. So follow the same procedure. Okay, follow the same sequence. If not, and then okay, I can also decide to actually work one with you. Then I'll give you this. I don't know the time as we speak now. The number of this thing that we have consumed. Please subscribe to Calendar Man. This is Calendar Man TV you are watching, and this is the total classroom that you can pass examination. Okay, you can pass and pass very, very well. So I'll be very soon be getting the signal to know where we have reached. Then we move as such. Is that okay? So now let us quickly look at just one of them and see how we can actually. Now let's look at another one. I could have solved many of them, but because of we're trying to limit our movement a little bit, because let me see if I'm able to get one here. Okay, let's see this one. Z is equal to x squared minus y squared plus 3xy. Okay, now here the z, the x is equal to what? Here we have what? 2x, remember? Then here also what? Plus 3y. Is that okay? 2x plus 3y. Then we have the z, the x is equal to what? The z, the x is equal to what? The y, sorry. The z, the y is equal to what? Is equal to negative 2y. Is that correct? That means this one will come and multiply and subtract 1 from it. And then yeah, y will find to plus 3x. Is that okay? Then we have all right. So then we have you want to do what? The square z over the y squared. What is it? If you are there, the y into bracket, the z, the y. So we have the y, but we know the z, the y to be what? To be negative 2y plus 3x. Now this y here telling you that you have to differentiate where there is y. So it becomes what? If you differentiate here, remember here is 1, it becomes what? Negative 2. Okay? And then the squared z, the x squared is going to be what? The x, the z, the x. So if I'm to write it, it becomes what? The x, then the x, the z, the x. What the z, the x? The z, the x is equal to what? 2x plus 3y. Okay. Now what did I say? Because of this x, you differentiate as well as this one is, and the answer is what? Is 2. Is that okay? Then we have the square z over the x, the y. This will be what? Will be the z. Then the down here is what? The x, the y. Okay, something like this. It's not 6, so please take note. So over and it is not 2, remember. So here we have the x. What is the z, the y? The z, the y is what? Minus 2y plus 3x. Now the trick here is that after you get this one, look at the letter here. It's what? X. Therefore you differentiate here, so the answer is what? The answer is 3. Exactly. I think I'm giving you some 2 or so that you will be working and then see if you can work it out. This is what? Is a partial derivatives that we are talking about. So very soon so go and try your hands on this thing. Z is equal to x squared plus y plus 1. Then the second one is z is equal to 2 x squared plus y. Go and try your hands on this. Exactly. Try your hands on this. So as we end this tutorial 4, we shall soon be moving to other ones, which is we will soon be moving to what we call the integration. From there, tutorial 5 is going to be integration, and that one also we are going to deal with it as such. Integration in different forms. That's what we're going to do. This is the end of tutorial 4. That is calculus tutorial 4. And this is the one, the partial derivatives. Please subscribe to Calendar Man TV. All that we are saying. If you don't subscribe, you'll not be able to get the input. You'll not be able to get what we are asking you to do. Is that okay? After you subscribe, it is free. Okay? Instead of struggling somewhere, sometimes you are working. Will you be having time to be doing some classes? But at the comfort of your home, even it's not even on your phone. Just subscribe. Just type Calendar Man. The calendar, some people make it. It is Calendar Man. TV. Okay, just do that on YouTube. It will send you there. Just subscribe and press the notification button. Share it to your friends. Those outside the country, whether you are in America, what do you call those Asian countries, wherever you are watching me. I'm saying that this is a powerful, and the language is the way I'm using it is very clearer. You'll be able to understand very well. Why don't you use it as your classroom? Because I'll be teaching a lot of things and be teaching in technical and others. Okay, I've learned a lot as far as I'm doing my PhD, and let me say that at the PhD we have a lot of things that these things they are appearing as we progress. You understand? So please try and subscribe. Please, Action Senior High School is a secondary school that you can try. You can when you call, tell Action, or when you call, tell him that you have the advert from the calendar man. He says you have to reduce the rate for you. So call Action on this number and then go for your, whether you are SHS student, you are doing remedial, whatever it is, whatever vacation. Please call Action on 020 89 85 488. So when you go, they will help you and you pass once and for all. Exactly. Thank you very much for listening. So we are from integration 5. What do you call the calculus? Tutorial 5 is going to be what? Integration and on and on and on. Thank you very much.